In the journey to find another Earth, researchers have turned their look to Proxima b, our nearest exoplanet neighbor. The most recent image taken by the James Webb Space Telescope shows a world that is both enticingly and alarmingly unlike our own. We have found a planet around the close-to star Proxima Centauri, yet this revelation didn't work out coincidentally. How's the nearest Earth planet you believe merits visiting? How challenging is the journey to Proxima Centauri? We are currently unable to travel at the speed of light, and it is more than 4 light-years away. However, there are plans that have set the stage for a shift in our approach to sending probes there. The most precise image of Proxima b that has ever been taken has recently been taken by the James Webb Space Telescope, which is considered to be the most advanced eye in the sky. We have made significant progress in our understanding of exoplanets and the possibility of extraterrestrial life thanks to this groundbreaking achievement. Scientists are able to examine Proxima's features in depth thanks to this image's unprecedented clarity, providing new insights into its composition and environment. We find ourselves at the crossroads of optimism and adversity as we investigate the mysteries of Proxima b further. The planet's close proximity to Earth makes it an appealing target for exploration, despite the formidable obstacles posed by its harsh conditions. In the following sections, we will decipher the mystery surrounding our cosmic neighbor by examining the intricate nature of Proxima b and the technological marvels that made this discovery possible. Proxima b, our nearest neighboring exoplanet, orbits the star Proxima Centauri just 4.2 light-years away from Earth. It is a prime target for scientific research and exploration due to its proximity. Proxima b remains a mystery despite its proximity, posing a complex puzzle that challenges our comprehension of planetary formation and habitability. Intriguing details about the physical characteristics of Proxima b have been revealed by recent measurements. The planet's minimum mass is 177% higher than Earth's, indicating that it may be closer to Earth than previously thought. This expanded mass could demonstrate a rough, Earth-bound synthesis like our own planet, adding to its charm. Proxima b finishes a circle around its star each 11.2 Earth days, a strikingly brief period that addresses its closeness to Proxima Centauri. One of the most intriguing parts of Proxima b is its area inside the tenable zone of its star. The region around a star where the conditions might be just right for a planet's surface to contain liquid water is known as the habitable zone, or Goldilocks zone. Because it is believed that liquid water is necessary for life as we know it, this idea is crucial in the search for worlds that might be habitable. It is impossible to overstate the significance of Proxima b's location in the habitable zone. It raises the tantalizing possibility that this far-off planet might contain liquid water and, consequently, some kind of life. This prospect has lighted the creative mind of researchers and the public the same, powering fantasies about finding life past our planetary group. Late progressions in innovation have considered more exact estimations of Proxima b's qualities. The coffee spectrograph, a strong instrument intended to recognize and study exoplanets, has given new experiences into Proxima b's tendency. These most recent measurements raise the possibility that Proxima b is, in fact, a rocky terrestrial planet much like Earth, increasing its likelihood of being habitable. However, there are difficulties in the Proxima b story. While the planet can live in the habitable zone due to its proximity to its star, it faces significant challenges as well. Proxima Centauri, a red small star, is more modest and cooler than our Sun, yet it presents extraordinary dangers to its planetary friend. Proxima b's ability to maintain an atmosphere is seriously questioned due to the intense radiation it emits. Without a defensive climatic layer, the planet's surface would be presented to unsafe heavenly radiation, possibly making it ungracious for life as we grasp it. This close dance between the planet and the star creates a precarious balance, where the very things that put Proxima b in a zone where it is habitable also put it in danger of supporting life. This strain among trust and difficulty embodies the intricate idea of exoplanet research. On the one hand, Proxima b's habitable zone location and mass that is comparable to that of Earth inspire optimism regarding its potential to support life. The harsh realities of its stellar environment, on the other hand, pose significant obstacles to its habitability. Proxima Centauri, the host star of Proxima b, is at the center of the story. This star is a red dwarf, a type of star that is very different from our own Sunday red diminutive. People are more modest, cooler, and definitely more various than stars like our own. The truth is much more nuanced, despite the fact that their cooler temperatures may appear to be beneficial to nearby planets. Because of its smaller size and lower temperature, Proxima Centauri has a habitable zone that is much closer to the star than our solar system. This zone is where a planet's surface might have liquid water. This vicinity makes a large group of difficulties for Proxima b, our closest exoplanet neighbor. One of the main outcomes of Proxima b's nearby circle is the probability of flowing locking. This peculiarity happens when a planet's pivot becomes synchronized with its circle, making one side generally face its star while the other remaining parts in ceaseless obscurity. The ramifications of this are significant. Envision an existence where one side of the equator relaxes in timeless light while the other never sees its sun. This flowing locking prompts outrageous temperature varieties across Proxima b's surface. The side that faces Proxima Centauri is probably very hot, possibly hot enough to melt rock. The dark side, on the other hand, might be stuck in a cold night that lasts forever. There may be a narrow band, known as the Terminator line, between these two extremes, where temperatures may be more manageable. This strange place addresses one of a handful of the areas where conditions might actually uphold life as far as we might be concerned. However, Proxima b's environmental difficulties do not end with temperature extremes. The planet receives a lot of radiation because it is so close to its star. Despite their smaller size, red dwarf stars can be extremely active and prone to powerful flares. Any possibility of life on nearby planets is seriously endangered by these stellar eruptions. In April 2021, stargazers noticed a flare from Proxima Centauri that was genuinely stunning in its force. This occasion was multiple times more extreme than any flare recorded from our Sun, exhibiting the unstable idea of Proxima b's inestimable area. Such strong flares could strip away a planet's environment over time, allowing its surface to stay uncovered to hurtful radiation. The radiation climate around Proxima b is additionally muddled by the star's attractive movement. Proxima b's high-energy radiation environment is thought to be caused by powerful magnetic fields created by Proxima Centauri's chaotic surface activity. According to researchers, the development and survival of life as we know it are significantly hindered by this constant radiation bombardment. Consider the following to put the magnitude of this radiation into perspective. Proxima b experiences radiation from the solar wind that is approximately 1,000 times greater than what Earth experiences. The majority of the living things that we are familiar with would be devastated by this never-ending assault of charged particles and radiation with high energy. It is natural to doubt the possibility of life on Proxima b in light of these harsh conditions. One researcher pointed out that while the idea of a planet that could be habitable orbiting Proxima Centauri is appealing, the reality appears to be far from that. An environment that appears to be hostile to life as we know it is created by extreme temperatures, radiation, and tidal locking. An additional researcher made the observation, it's difficult to imagine life surviving such intense radiation without specialized shelter. The difficulty that any potential life on Proxima b will face is summed up in this statement. Organisms would need to come up with extraordinary adaptations or find ways to hide from the constant stream of radiation in order to survive in such a setting. However, it's memorable's pivotal that how we might interpret life and its potential structures is restricted to what we've seen on the planet. The difficulties that make Proxima b appear uninhabitable also force us to broaden our ideas about habitability and life itself. Are there organisms that can survive in what we consider to be extreme conditions? Could Proxima b's unique environment support a diversity of life forms unrelated to our own? Notwithstanding Proxima b's outrageous climate, mankind has adapted to the situation with wonderful mechanical developments. At the front of this try stands the James Webb Space Telescope, JWST, a wonder of designing that has upset our capacity to study far-off exoplanets. The JWST is a significant technological advance in space observation. Astronomers can now see through cosmic dust and gas thanks to its advanced infrared imaging capabilities, which reveal details about exoplanets that were previously hidden from view. This breakthrough has made it possible to image Proxima b with unprecedented clarity, which has been especially important to our research. What makes the JWST's ability to study Proxima b so unique? The response lies in its complex setup of instruments and its essential situation in space. The JWST is shielded from the interference of our planet's atmosphere and the Sun's heat by orbiting the Sun about 1 million miles away. This ideal situating, joined with its enormous mirror and delicate locators, permits it to catch the slightest signs from far-off universes. The JWST can do more than just take pictures. Its instruments are able to analyze the light that passes through the atmosphere of an exoplanet, providing important information about its composition. Biosignatures, also known as chemical markers that could indicate the presence of life, can be detected using this method, which is called spectroscopy. While the JWST has received a lot of attention, it is not the only technological marvel that has helped us learn more about Proxima b. Our understanding of Proxima b has been greatly improved thanks to the spectrograph, a device that looks for minute changes in a star's light caused by planets moving around it. New insights into the planet's mass, orbit, and possible composition have been provided by this high-precision instrument that is attached to the Very Large Telescope in Chile. The mix of information from the JWST and coffee has provided researchers with a more exhaustive comprehension of Proxima b than any other time in recent memory. We are getting closer to answering the fundamental question, which is whether or not Proxima b is a planet that can support life. The idea of sending a probe to Proxima b becomes increasingly feasible as space exploration continues to expand. Perhaps of the most aggressive task in such manner is the cutting-edge Starshot drive. This undertaking imagines sending minuscule, light-fueled shuttle to the Alpha Centauri framework, home to Proxima Centauri and its planets. Earth's powerful laser beams could propel these nanocrafts at a significant fraction of the speed of light. They would be able to reach Proxima Centauri with this strategy, if it works, in just over 20 years, a fraction of the time it would take with current technology. The possibility of visiting Proxima b, even with a test, is an overwhelming test. This is a difficult task because of the sheer distance, more than 4 light-years, and the need for precise navigation, communication, and data transmission over such vast distances. However, there are a lot of potential benefits. If the mission is successful, direct observations of the atmosphere, surface, and potential life forms on Proxima b could be made. As we stand on the cusp of these phenomenal revelations, considering what Proxima b represents is significant. Even though it is harsh and difficult, this faraway world embodies the spirit of exploration and the pursuit of knowledge that propels humanity forward. It reminds us that our quest to comprehend the universe has only just begun, and that it is vast, mysterious, and full of surprises. All in all, the revelation of Proxima b and the headways in innovation that have caused it conceivable to address a critical achievement in our investigation of the universe. Even though life on Proxima b is difficult, we still have a lot of potential for new ideas and discoveries. We are reminded of the limitless possibilities that exist beyond our own solar system as we continue to decipher the mysteries of this faraway planet. The account of Proxima b is nowhere near finished. As we look to the foreseeable future, we can anticipate additional revelations regarding this mysterious world and the place it occupies in the universe. One of the most exciting and profound scientific endeavors of our time promises to be the investigation into Proxima b and the many other exoplanets still to be discovered.